What's up, YouTube? Welcome to this part 3 of ASP.NET Core Worker Services and SignalR. In this final episode on this series, we're going to complete out the application. I'm going to show you a bunch of other demos that are like IoT demos. I'm hoping to pique people's interest in IoT as well, but also to show you what you could possibly do in case you're not quite clued into all of those kinds of things. I've got 2 demos that I'm going to show you today very quickly. Both use the ASP.NET Core, SignalR, and other message brokers such as MQTT, which is a different sort of protocol from MQPS, but RabbitMQ actually supports MQTT as well. So you could use RabbitMQ for MQTT as well as Service Bus and things. So it's just a continuation from last time's project. Just complete out a bit of things. But before that, let's do this demo. So what's this demo about? I'm going to record this on my phone here, so just bear with me. All right. So the first demo is sort of a simplistic version of it, where I have these are regular light bulbs. They're working off of the wall socket. So it's a bit dangerous. It is plugged in right now, so it's got all these live connections here, which I've got to be careful not to touch. A lot of the circuitry here is also live. Some of this area here is all live. While this side is sort of the low voltage areas, that's the microcontroller, which is Wi-Fi enabled. And the idea is that microcontroller is a subscriber to messages that will effectively come from an ASP.NET application from a browser. So the browser is able to do things on the browser end that will go through this whole process here. As you've seen in the past, if you remember this part here. So imagine the browser here is going to use WebSockets or SignalR to talk to our ASP.NET server side. That server side application will publish a message to a message broker. And in this case, we have another device. This is not the device I'm showing you here on the screen here, but more another device that's going to take that message broker service bus or RabbitMQ message, or MQPS message or that protocol, and convert that to MQTT, which then publishes out to an MQTT broker, which is not here on the screen. It's just like any other message broker, just a different protocol. And then this little device here is the subscriber to that. So I'm going to show you that application working. It's not the one we're building today, but we'll get to the point where you'll understand how to build something that could do those kinds of things, right? So of course the device has already been made. It's nothing to do with this actual project. But since the control circuitry of this is using SignalR and ASP.NET Core and Worker Services, I thought I should show you that as a demo. So here goes. So I'm going to browse to my IoT website, which is iot.matlabs.com. And over here, I got a IoT controller and I've got a command center here. Now I'm going to also split this up into another window just to, all right. So now if I were to turn this light on, ideally the big light bulb here, the same color, should turn on. Okay, so I'm going to try and show you the screen recording of the phone along with my screen. Hopefully I can, in edit, I'll make it so you can see it all working. So I'm going to turn on the red light here, and that you can actually see the glow. I don't know if you can see the glow on my hand. Let's see. Yeah, so red light on. And of course, you can see it down here. It's on, green light on, blue light on, and off, and off, and off. Right? Now, what I'm going to show you here is slightly different in that this particular device just has the light bulbs on it, does not communicate back to this service to give its status, if you will. Right? So, but there's another device I'm going to show you now, the next demo. That's a smaller version of this LED thing, as in these light bulbs. These are real light bulbs, working on mains. I'm going to show you another device that's using LEDs. It lights a bit dimmer, but it's got a bunch of other things on it. I will play with that. And it provides feedback or status of its state. So as we modify the state of that device, it publishes its current state back. And that the subscriber here, again through SignalR or WebSockets, is repainting let's call it the dashboard based on the status of that device. So it's pretty cool. It's like a two-way conversation going on. I turn on light bulb. It says, okay, light bulb is on. I get confirmation here to this browser UI saying light bulb is on. And there's a bunch of other devices also that we're going to be operated on. So I'm just going to swap the devices out. I'm going to turn off this one here and move another one in. All right. So it's the similar microcontroller here that's connected to Wi-Fi. It's powered up through a separate power supply. And we have these 3 LEDs here, which are very dim, but hopefully you'll see them. And then we have a motor here, DC motor that can go clockwise, anti-clockwise, and different speeds. So we can control that to the web UI front end. And then there's a servo here. I won't be able to turn it now, but these servos they're not motors, they're servos. So those of you know what a servo is, you'll understand what this thing is doing. I can't actually move it, but I can move it through software control, right? So the browser application here, I'm just going to reset all of that. Okay, so now a few things are going to happen. This device here is also got a temperature sensor and humidity sensor over here, if you can see that. And so you can see that in this point, the temperature or humidity is 47% and temperature is 68, which I don't think is the right temperature, but anyway, that's what it's showing, 68.7 degrees centigrade, Fahrenheit, and 45% humidity, okay? If I were to touch that sensor, like heat it up a bit with my hands, which I shall do now, there, you should see this temperature moving up. There, this is shooting up, right? So that's my body temperature. So it's going to come back down slowly, humidity as well as temperature. So as I said, this device is publishing its status every 5 seconds or something. And anyone could be listening to that status. This browser front end is actually using SignalR and directly subscribing. You remember one of the things that WebSockets allow browsers to do is it's a web socket. It's a socket. It allows browsers to become or utilize any kind of socket they desire, not just HTTP. So we actually have a library that allows us to talk MQTT from the browser using WebSockets directly and subscribe to the brokers. The same with the AMQP. There are JavaScript libraries that allow you to subscribe to an AMQP or AMQPS message broker directly from the browser. Don't need the sort of the server side thing. So this application here is using WebSockets, not necessarily SignalR, but WebSockets, and directly subscribing to the same message broker that this thing is publishing its status to. Hopefully that's making sense. Okay, so now here's the fun part. I'm going to first of all just turn on lights on and off. Hopefully you can see that. So you can see the red light is come on, red light is off, red light is on, green light is on, green light is off, green light is on. And this is instantaneous. You could be anywhere in the world controlling this device from your machine. If I had this thing running and you were on that website, you could be, you can go there right now and do it. But by the time you do that, this device is offline. But that's what's going to happen. It's going to control the device from wherever you are through a web browser or phone app or whatever, right? Blue light is on, blue light is off, green light is off, and red light is off. Okay, now what I'm going to do is I'm going to use the motor speed control here. You'll be able to hear the motor. You won't be able to see it turn because it's just spinning. I'm going to see the angle from the top to see if it's spinning or not, but you'll hear it. So I'm going to turn the motor on because the speed is 0. And you can see here, the feedback from the device is also saying that its speed is 0, 0 RPM. I'm going to bring it up. You can see the speedometer kind of went up here. And I can move this and you can hear the motor speed, okay? So that's the feedback coming back from the device to give you the RPM. I'm just going to slow it down a bit so it's not so loud. Okay, and I can also turn it clockwise, anti-clockwise. This direction is showing this is counterclockwise, and that switch here, it's not I can't operate the switch, but it's showing me the status. So if I turn this motor off here, right? That's the switch. Now I change the direction here, and it'll show me the status of the device. When I change that, of course, you'll hear the motor sound as well. See that? I'm going to turn that motor off so you don't need that sound. Okay, so now we're going to move this this servo control, this servo here. The servos are kind of like motors, but they are extremely smart motors. They also hold their positions. They're very difficult to twist or turn. They're not intending. They're intended to use to twist or turn something and hold that position. So depending on the kind of servo you buy, and heavy duty or not, they are so strong that you cannot fight them. And even if you try to twist them, you won't be able to twist them. And if you try to stop them from moving, you won't be able to stop them. This is, of course, not one of those kind. This is a hobby version of the same thing. But you could use this to turn doorknobs or something, like something heavy duty. All robots use these things to move the entire robot and arms and lift things. So they're very strong. The quality they have is they hold position. So you can tell them to go to a certain position and they'll hold it. If they can't get there, they'll keep trying to get there. So they're never going to give up because they know they haven't gotten there yet, the position, right? So I'm going to change the position. You can watch this device here. Yeah. Hardly any lag. You can see the dial here. This is a 180 degree, almost 180 degree positioning from this position. So you watch here, a little more than 180, right? But generally you don't want to push them beyond the 180 mark. So they're intended for the 180 degree kind of twist. Some are continuous, but this one is not. Okay, so this hopefully will give you an idea of what's possible and how these technologies can be sort of married together. WebSockets or SignalR in .NET Core. SignalR and .NET Core for me is synonymous to WebSockets. It's just a library on top of WebSockets primarily, but also that library is allowing us to support older browsers or older devices like phones and phone browsers, for example, that don't support WebSockets. So that's the basic purpose of SignalR. The worker services are allowing us to have background services that are running, listening to messages without impacting kind of the normal running of the application. So both these, this application itself, the background has got a kind of worker service that's doing that listening to messages and rerouting the messages to the browser, or from messages from the browser being rerouted back to some service broker or something, further out from there, right? Okay, so now what are we going to do today? We're not of course going to build that and build the device here, but what we're going to do is hook up the browser to talk back to the server. We did that the last time. So the browser, we hooked it up such a way that the browser could talk or send messages to the server. And we kind of stopped there. So in today's video, we're going to take that code and extend it further, where that message received is going to be published out to some broker. And that'll be received by another application, a completely different application. That's like a console application. That'll be the server subscriber to that message. And we're going to use that feature to trigger off the publishing of those titles. So I'm going to run the application the way it is working right now, so you understand what we have. And then I'm going to say, okay, now we're going to modify it like this to do that. Okay, so let's do that. Let me also just turn these devices on. If you do like these IoT devices, I don't know what your interest levels are. This is a very, very big thing for me. I love electronics is my first love. Software programming is my second love. So I'm cheating on electronics by doing software all these years. But basically, this is something I just totally love. But if you also like the same thing, let me know in the comments. And maybe I can have a bunch of videos later on. I do plan to at some point. I keep planning to do these things, but I don't want to bother software people from too much of the IoT hardware kinds of things. But I think it's a cool new field in our world of software. And people should be, I'm hoping to encourage people to get interested. Okay, let me turn this off. All right, so now I'm going to just run the application. So we have the application we built last time. Okay, I'm just going to run it so you understand what we have. what's in place, and then take it from there and extend it further. So this application, this is the browser application that has the SignalR in the front. There's another application that was publishing messages to this application, completely different application that's publishing messages to a broker. The worker process, a worker service in this application, ASP.NET Core application, is a subscriber to those messages. It receives the messages, and then through SignalR, it publishes the messages here in the browser. All right. So I'm going to run the other application, which is the code for which was not available before. I will make this available once we finish with it today. And so it says press enter to publish messages. You can see the browser is not receiving any messages right now. I'm going to hit enter and starts to publish messages. It's got publishing a message 1 per second. All right. This is what we had last time. Now, we'd also hooked up one of these buttons, all these buttons back to publish or talk back to the server side. Now, you could do this through Ajax or JavaScript, what are we going to call that thing? But since we have a WebSocket channel open, and remember, WebSockets are full duplex. What does a full duplex mean? It means on the same connection, on the same channel, both sides could be communicating at the same time. While data is flowing from the server to the client could also be talking on a completely different topic. It's not like a response to the sort of the question, if you will, doing completely different things, but the client is able to talk back to the server. So it's a full duplex. So if you have the channel open, since we have the channel open here, why not just use that? It's much faster, lightweight. Use that channel to talk back to the server. So we did that hooking up last time. Okay, so what will happen here was in our application, we have this hub, and this hub has a method that is published called command received. And then in our, I'll show you the JavaScript side here, we had subscribed to all our checkboxes to some callback, and we are using the SignalR connection to invoke this method, the same method, command received, so case sensitive and everything else, right? So we are really invoking this command received method in our hub, and it gets 2 arguments, a light color and a state. State is like a bowl, light color is red, green, blue, right? So we did this here last time. So what I'm going to do is just put a breakpoint here so you can see it happening or working. I'm going to put a breakpoint here. I'm going to go into the browser and sort of turn these light switches on or off. Okay, so it hits it over here. You can see the light color is red and the status is true, meaning it's on. And here it's doing nothing right now, but we want to publish a message out to a broker. And similarly, when we turn it off, it comes back here, same light color red, but this time the state is false, right? Okay, so I've got the code ready. I'm going to just paste bits and pieces of it, so I'm not kind of pasting a whole chunk of it, so you can hopefully keep up. The source code will be available on my GitHub as like the part 3 version of the source code, so that way you can use the final version of the source code to kind of take it further, all right? Okay, so what we need to do here is publish a message to a topic or an exchange, providing it with some information here, and the receiver can do something with it. Now, what we want in this particular case, I'm not going to turn lights on and off again or anything, but what I want to do is have the browser, remember how we had to start this application from publishing messages, right? So when we run this application here, it says press enter to publish messages. I don't want it to be done separately. What I want is for the browser to tell this application, okay, start publishing messages, stop publishing messages, start publishing messages, stop publishing messages. So I want it under the control of the browser, right? Rather than doing it on a separate application. So the buttons, the events, are going to publish messages back to this application, which is a completely different application from our ASP.NET Core application. It's a .NET Core application, but not part of the same application. That's the subscriber to those messages. It's going to receive the message and say, oh, you want me to turn it on? Publish messages, it's going to start publishing messages. Oh, you want me to stop publishing? I'll stop publishing. Right? So it's under the control of the browser. And we'll see the messages appear in the browser or stop appearing in the browser as we turn the switch on and off in the browser itself. Okay, so that's the point. So towards that end, I'm going to go back to our SignalR application here. Over here, we need to, of course, first define sort of a DTO that we're going to use to publish that. So I have a DTO here that I have defined already under models, and it's called the command message. So the topic is going to be the command topic, and the topic we're going to be publishing to, or the exchange we're going to be publishing to, is going to be called the command topic or command event topic, and that's the data. So we have the light color and the state, in addition to some unique ID and date created and all that. Okay, so that's just a simple DTO. We need to be able to publish that over here from the hub. But remember, the hub, we don't write the code in the hub. We use the code at the hub as a SIL, as a service interface layer. That, in other words, is going to interface with our system. We don't write the code in the hub. Okay, so our system has the ability to publish these messages. It knows where to publish, what to do, and all that. This hub is just saying, hey, I got this, light color and the state, publish it. You do what you have to do. I don't really know what it is. The hub is simply the conduit, the way for us to interface with our system. All right. So now this brings me to another topic that I think some people are hoping to have answered. I'm going to pull up the worker service, and you can see in the worker service that we created our own instance of this is my system, right? The Signal Processor Manager is the system. Everything is kind of hidden behind this and all the other classes that, that might be behind that. And the question is, do we want to create another instance here? Should we register this with the DI framework in .NET Core and do it that way? You could do it that way. It doesn't, to me, it makes no difference. I don't care, because it's just, I'll play along with whatever the SIL requires it to be, but I don't actually use dependency injection myself within my applications. But in this case, it's the SIL, and the SIL says, hey, it's a nice way to use dependency injection for you to get an instance of your system, right? Yeah, if that's what it takes, then I'm willing to do that. Right now, it's not using the dependency injection framework. So we could do that way, or we could just make this a singleton by itself, but it's not. By itself, it's just a class. I can create any number of instances of this class, and maybe I don't want to or don't need to. So I'll probably use it as a singleton. It's been programmed to be actually a singleton. Not that it's inherently a singleton, but it is programmed to be a singleton. You can have multiple threads partying on the different methods in the class without any hitch or glitch with regards to thread safety. All right. Let's register that manager with our dependency injection framework in .NET Core. Okay. So once we've registered the manager, then the publisher, the message broker, PubSub worker, which is the worker service, as well as the hub, could both rely on this being available in the dependency injection framework. So I could actually modify this class to say, instead of doing it like this, let me get that as a argument, constructor argument here. Oh, the signal processor is internal, is it? Yes, we'll have to make this public. This might cause a whole host of other issues. Yep. Let me fix that. Okay, not too bad. So far what I've done is we had the signal processor being constructed here in the member initializer. We modified the constructor to ask for the DI framework to provide us with that instance. And since we registered this manager with that as a singleton, we'll get that instance here. And we could do the same for our hub. So this is the background service. On the hub, I'm going to do the same thing. I don't actually need this here, so I'll just remove that. But I'll ask for it in the constructor like that. And then that. Okay. So they're getting an instance from the dependency injection framework. Since this registered in the dependency injection framework or with the dependency injection framework as a singleton, it's going to be the same instance, which is fine. As I said, this class has been designed and implemented in a way that it is safe to use as a singleton. Right? You have to design classes to be usable as a singleton. They're not just automatically going to be safe. You got to make sure they are safe. All right. So now that we have that in the hub, what we want to be able to do then is use that instance over here and publish the command message, providing it with a new instance of a command, which of course takes these different arguments. As you can see, some ID, the light color, which we have here, the state also, which we have here, and the current date time. So let me just fix that up. Okay, so that's all the different arguments. And this is awaitable, so we need to wait that, which means this needs to be async task returning, and we don't need this. Okay, so essentially we are calling the publish command message method, providing it with the command message. We're using the light color and the state as our information here in this instance, and that's being published. And because this method is asynchronous, we awaited that and modified the method to be async task. And since this method is awaitable, we've modified this method to be async task returning. Right? So far messages are being published. Now the idea is in the other application that we have here. Currently we don't have the subscriber going on. What we do have is a factory that creates a publisher. So we could have another factory that creates a subscriber and uses the same broker, whatever that is, with this RabbitMQ sales bus. And so we could have a message broker subscriber factory that'll create for us a subscriber that subscribes to the same broker, and of course topics and whatever. I'm going to just, the code will be there. I'm not going to actually spend a lot of time explaining all that part. That's done many, many times over. So I have a factory. So they both respond to the same message broker type here. And the factory will create an instance of RabbitMQ if it's set to RabbitMQ, or it'll create an instance of a service bus subscriber if you set that to that. Once we have a subscriber and it subscribes to the topic, the queue exchange, or you want to call it, queues in RabbitMQ and subscriptions in service bus. I prefer queues. It's going to receive a message. Effectively, that message came from our browser, right? The browser sent, using SignalR, sent that information down to the server side, our server application. The server application published that message to RabbitMQ or service bus. This subscriber here will receive that message. It'll get an indication of whether we want to turn messaging on or off. And then this application has to respond to that message based on, let's say, the state of the light. We don't care for the color so much, but if the state is on, start publishing messages. If the state is off, stop publishing messages, and keep being able to do that on and off kind of repeatedly. Now, we only have 500 messages being published one message at a time. So you might have to have multiple loops to keep that going past 500 to kind of loop back around and continue on. Okay, so that there may be a couple of nested while loops just trying to handle that whole aspect. So that's not the point of this thing. So I'm going to modify the code here. This for each loop is probably going to be inside of nested while loops to handle that scenario. I'm going to take that out, and basically even once we subscribe, as soon as we receive a message to start publishing, it's going to go and start publishing here. So we don't need that here. Then just change that message here also a little bit to say, instead of pressing it, we're just saying waiting for message to arrive or something, that does that. All right. All right. So what I've done is I've got a subscriber factory now that creates a subscriber based on the same message broker type. And then the subscriber subscribes to the event. It receives the body, if you will, that gets serialized to then a command message. Is the same command message that we had in the other project that has the light color and the state and creation date and ID. Nothing different, same thing. So we have a command message, and then based on the state, whether it's true or false, we will publish messages or not publish messages. That's set up here. And then we have, as I said, there's one do while that just will continue to just loop through that. And then here, if publish messages is true, it's going to come and start doing that. And after it's published every message, also again checks to see if we've asked it to be turned off or not. And if it's not, it breaks out of this for loop, which then exists from the while loop, and then it gets stuck in this outermost loop till we publish another message to say turn it back on. It comes back on, right? So even though this part seems complicated, it's really not that, and that's not the point of this exercise itself. So I'm going to run this application. It's not going to start publishing messages, but it's going to wait for some application to publish a message saying start publishing, right? So let's start this. It's going to just sit there and wait, hopefully. Yeah, so waiting for start publishing messages. Waiting to start. Okay. And we run our browser application. All right, so no messages are being published, even though the other application is running, but it's waiting for us to publish a message, which means it has to come from here or any one of the buttons. We don't care for the color, it's just the state that matters to us. And it's going to come in. And so basically from our, why is this calculator open? From our browser side, it's going to come into the hub. It's going to be received here. It's going to publish that message to, in this case, RabbitMQ. Then the other application, which is the other code here, is going to receive that message. It's going to extract the data itself, deserialize it, and then look at the state property and set this variable to true or false, and then currently is false. So when you receive the message with the true, it's going to say true, and it's going to start publishing messages, right? Okay, let's try that out. Let's check that out. So now I turn it on, it's publishing messages. If I want to stop it, stop. Any one of these buttons could be used, since we don't care for the color. Publish messages again. Turned off. So this is showing you how the browser could be talking back to the server side using WebSockets or SignalR. And then from there, what you do is totally up to you, right? You're essentially having this two-way conversation. The big part really, of course, with WebSockets is allowing the server to send data to the browser more than the browser to send data to the server. We've always been able to do that with HTTP, not necessarily WebSockets with that lightweight, super fast protocol. So if you're sending a lot of data back and forth, and of course that full duplex channel was never available with WebSockets. So of course with WebSockets, you get that full duplex channel between browser and server. But for the most part, it's the ability for you to send data from the server to the browser for notifications and a bunch of refreshes of screens and things of that nature that previously required the browser to keep polling the server to see is it done, right? And of course with the worker services feature of .NET Core, we are able to have a web application that also happens to be kind of listening and waiting for stuff to happen, typically like, long-running processes or applications that are just doing things in the background, if you will, but they're not interfering with the web application aspect of things. Now, when you deploy into the cloud, you do have to be careful, as I mentioned in the other very first web worker services thing. You could have multiple instances of these worker services that may not be what you want, right, or expect, right? So your design has to account for the fact that you'll have multiple instances of the same services running because you happen to scale out horizontally your web application, 3, 4, 10 instances. And so you may not want, 10 instances of a broker or your message broker subscribers, so you have to be worried about that. Okay, so I hope this has been fun. I hope the series has been fun. I've enjoyed doing it. I hope you guys have enjoyed doing it. I hope you enjoyed the IoT demos to the extent that, I don't know how many people are actually interested in this sort of thing. I think it's really cool. Anyway, I hope you enjoyed that as well. I hope you learned a whole lot of things here with SignalR. For the time being, this is the end of this series. Maybe we'll talk about SignalR and worker services or something at a later point for a completely different context. But I think for now, I've kind of beaten this thing down completely. Not much more to go. But I hope I've given you some food for thought, some ideas for where and how you could use these technologies. And of course, the basics of what these technologies are and how they work. That's of course more important than like how to use it. All right. I hope you've enjoyed this stuff. If you have, please give me a thumbs up. Please subscribe. Please hit the notify button. And I shall see you next time.